Okay, hi my students. Here I'm back. Just want to make sure we clarify. Today I want to show in this video why sine inverse of negative of x is minus sine inverse of x. So now in order to prove that, I want to show last class we have seen using the unit circle, and you can clearly see the y coordinate with the help of y coordinate. So I try to create how to find the inverse trig function. So I took the angle from negative 90, negative 60, negative 30 until 180. It means I'm going in the clockwise direction, starting with this angle which is minus 90, then this angle is minus 60, this angle all the way down is, sorry, not this, I'm not taking this one. I'm going to take this part, which is a minus 30 degrees. So this is 30, and not this, I'm taking this one, 60, and then 90, that's 90. And then you can clearly say, oh, these are the ones which you can clearly see. So basically I'm taking from negative 90, and then negative 60, negative 30, 0, 30, 60, 90, 120, 150, 180, 210, and so on. So I try to take some of the ordered pairs for trigonometric function sine, and you can clearly see I begin with minus 90 and went all the way till 180 degrees. And we have seen negative 90 is minus pi by 2, minus pi by 3, minus pi by 6, 0, pi by 6, pi by 3, all this until pi. And the values are this, which we already know. One is either you remember this, or I also showed you the shortcut how to get directly all these values. What you see is, how do we find trigonometric function? We only swap the input output. So what I did was, from this table I created another table where the red numbers, the output here is right here, which is from minus 1. So you can, the maximum you see is 1 and the minimum is minus 1. So you see that minus 1. So this is the output. And the input, the output of this is becomes the input. The input here is the output. So just swapping. The question is it going to be a function? So the last class we saw that if you use the whole data from minus 90, 180, you see that this 120 is repeated. So if you see this 120 is root 3 by 2, and you also have root 3 by 2 for 60. Then 150 is half, and you also have 30 is half. So these are repeated. So it's like you get two inputs giving the same output. So it's like a many-one function. So when you try to reverse it, what does occur is the half, which you see, the half gives 30, and also the half gives 150. So one input in the, when you swap it, this the inverse relation, I call it inverse relation because this half and this half gives two values for output, which is 150 and 30 degrees, which is pi by 6 and 5 pi by 6. So even though this is a inverse relation of this function, but it is not going to be a function. The reason is one input has two outputs. So that's why what we do is we try to restrict the domain of this. So the restricted domain is only taken from minus 90. So the domain is here. So minus pi by 2, less than x, less than equal to pi by 2. So this is the restricted domain. And the range here is, the range is from negative minus 1 to 1. So here, sine x. So when you reverse, it just does the opposite. So the inverse function is defined with, this is how it is written now. We've seen why it is sine raised to minus 1. This minus 1 doesn't have no value. It only means you are going backwards. It's like, now the reason I'm using is, look at this. Instead of sine inverse of x, you also use, so instead of calling it as sine, this one, it is written as arc sine of x, because you are using from negative 90 and it goes to negative 60, negative 30, 0, 30, and 60, and 90. So all these values cover the sine value from -1 until all the way to +1. So that is the reason it's called the arc, because of this semicircle arc. Or you can just write it -1. My goal here is, once we know this, how do we graph this? So we also seen last time is, I'm going to graph right there the same thing with this graph. So this -1. Only thing I want to make sure, there are some √3/2 and there is also half. So what is √3/2 value? I take √3/2. So √3/2 is 1.73 divided by 2 is 0.8 and 6. So almost equal to 0.9. So what I did is on the grid here, on the x-axis I took multiple of every two spaces I used like a 30 degree, 30, 30, 30. That means 30, 60, 90, 120, 150, 180. And on the other side also. Then on the y-axis, then what is pi by 6? Because pi by 6 is 3.14, and if you work this out, you get almost like 0.52, which is, I will just take it like almost 0.5, little more than 0.5. So that's why this two spacing, even though it is 30, I will consider it like a number 0.5. This is like 0. This becomes 0.5 is 1. So this is like a 1. This is pi by 2 is also 3.14 divided by 2. We'll get 1.57, which is almost 1.6. So this is like, I will take it, consider like a 1.5, just for see how the graph looks like. So this is again 1.5. So this is 1.5. So every two space is like 0.5, 0.5, 0.5, 0.5. Same thing, 0.5, 0.5, 0.5. So let's graph it. So how does the sine inverse graph look like? So first we will see how the sine inverse function look like. So I'll start with the bottom part to make it easier. 1 goes to 90 degrees, which is pi by 2. So if it is 1, so where is 1 now? Remember, two spaces is always like a 1, so this is like a 1. So this one is 90 degrees, so that part is taken care here. Then this is 0.8, which is 0.9, that's what I said here. So 0.9 is almost like 60 degrees, that is pi by 3. So where is 0.9? Now 0.9, if this is 0.5, 0.1, 0.9, I can split this in 1, 2, 3, and 4 and 5. So this is like almost 0.9 between the 0.8 and, so somewhere here. So this will be pi by 3. So pi by 3, remember this is two spaces. Pi by 3, again I forgot to write, is 3.14 divided by 3 is 0. So 1 point, yeah, pi by, it's two spaces, right? So again I will take it like a 1 because every two spaces. So this number here, which is 0.9 or 0.886, which is 0.8, almost like 0.86. So this point is this one. Okay? So again I repeat, this is 1 is minus, so this 1 is minus pi by 2, so plus pi by 2. This one is √3 by 2 actually. 3 by 2 is, this is like a pi by 3, this is pi by 3. And this is like pi by 6. Almost equal. And the same thing I can do here also. This is like minus pi by 6. This is minus pi by 3, and so on. Okay, the next one is 30 degrees. The half is 30. So this is half. So 0.5. So 0.5 is 30, and the 30 is pi by 6, which is this one. Then you say 0, 0. And the same thing on the other side, minus half is minus pi by 6. I'm not using the 30 but minus pi by 6. So minus pi by 6, this one is half, and minus root 3 by 2, and basically root 3 by 2 is minus 0.86 somewhere here. So I can split this into 1, 2, 3, 4. So between here, so this will go minus pi by 3. There you go. And minus 1 is minus pi by 2. So this minus 1, so where is minus 1? I made a slight mistake here. This is minus, yeah. So this part is correct. So this becomes here. And this is minus 1. So minus 1 is, this is 2 and this is 2. There is something 60. I think I made a slight mistake here. Yeah, correct. So the thing is minus 1. So the question is minus 2 spaces is minus 1. So this is minus 1, right? So this part is minus 1. And like how I took this one and this part is plus 1. And likewise you take that as minus 1. So this goes right here. Sorry. So this goes minus pi by 2. And this between 0.860 root 3 by 2, that will go somewhere here. Okay, so that's a lot of confusion. Hope that makes sense. I'm just trying to show it's not possible to get exact value, but want to make sure that even though this number is minus 1 is because it's minus 60 degrees. I can, if there's confusion, we can take off the 60 degrees, 30. But our goal, our number is to be used is minus pi by 3. Pi by 3 is 1. So it's like 2 spaces. 2 spaces is 1. So that means this is 0.8 here. Right here is minus 0.8, which is actually minus root 3 by 2. So same thing. And then now you can easily graph. Okay, and you can clearly see that. So this is the graph of the function. This is the function sine inverse of x. Okay, one thing you can watch this by, if you watch this, this is 1 pi by 2, this is root 3 pi by 2 is pi by 3. If you see on the other side, this is minus 1 minus pi by 2. This point is minus 0.86, which is minus root 3 by 2 is minus pi by 3. This point is, this point right here is half, which is half is pi by 6. But the other side, it's minus half is minus pi by 6. What I'm trying to say is, show is here that this graph, sine inverse graph, is also odd function. Now, what is the meaning of odd function means? Let's see. What does it mean is sine inverse. And I'm just going to give you one example here. Let's see if I start with this one, this point, sine inverse. Let me take this off here. Sine inverse of minus root 3 by 2. You see, the answer is minus pi by 3. But this is same as pi by 3, you get sine inverse of root 3. So this pi by 3, this minus stays here. So this is sine inverse of root 3 by 2. And clearly see this is working. That means if this is like AB, so this is AB, then there is a point on the other side which is minus A minus B, which is the definition of odd function. So by look, you can clearly see sine inverse of minus root 3 by 2, which is right here, is minus pi by 3. And then pi by 3 is the inverse of root 3 by 2. So the identity is already done that if you have a negative, so it is negative sine inverse by just using the graph. This proof. So this is proved with the help of proved by graphing. So this is using graphing. Okay, so just wanted to, two things are happening here is one is, do we know how did the sine inverse exist? Do we know what is the domain and what is the range? You can see domain is from -1 to +1, and the range is from -π/2 to +π/2. And here is the graph that the sine inverse graph goes this way, and the lowest it goes to -π/2, and the maximum is π/2, and it's between -1 to +1. Now don't think about the 60s, I don't want to get too much this part, so let's take off this thing to avoid confusion. That's it. So, but this proved is because using the graph and the points. But how do we do analytically? So let's prove by analytically. So I will start with, so we want to know why is this, right? So let's see why. So let's put sine inverse of -x is, I'm gonna put some maybe theta, okay? Let's put it, we don't know. So then, by definition of sine inverse, this -x equals sine of theta, right? Then you might divide -1 both sides, or you can, instead of divide, just multiply -1 both sides. So multiply -1 on both sides. So you multiply -1 and -1. This x is minus sine of theta. And remember, this is same as from the trigonometric identity, minus sine theta is same as writing minus sine minus theta. Now you use the definition of inverse function. So if you sine minus theta is x, we can write this back to sine inverse of x equals minus theta. And then you replace this back here, which is sine inverse of, I missed that, minus sine. Okay, and then again you multiply multiply -1 both sides. So -1 you multiply both sides. So this will be minus there the proof is. So the goal is this correct? So I want to, and that's what the proof, the video was. This video I created just to get a hang of, okay, that's the graph inverse function, and then I showed you also why it is, how it is, and I also showed you kind of representation that pi/6 means 0.5, or pi/2 is 1.5, and pi/3 is like 1. I'm using that idea just to get the whole graph. And I hope that helps. The next video I will show how do you get cosine inverse, what is this cosine inverse? Then you just call it like f of x. What does that mean? How did you get? What's the domain? What's the range? How the graph look like? And what do you think is cosine inverse of negative? So that's the next video I'm going to go. Thank you so much.